Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today I wanted to just give a little bit of an overview of magnetic loop antennas without necessarily referring to specific brands or anything like that. But there are a number of factors with magnetic antennas that are important to know about. Let's look at the overhead. The way a modern magnetic loop antenna works is it's a piece of pipe or coax or something about like this, and it comes down here. It's closed here. This is about 3 feet or 1 meter. Okay, up here at the top or at the bottom, doesn't matter, is a capacitor. There's no coil down here. The wire is the coil. It's one turn. And yes, you can do magnetic loops with more than one turn if you want to go down in frequency and not have them be too big. The way they are fed is by a loop down here. Now this loop is technically balanced, but it's often fed just with coax. Okay? And you can change the gain of the mag loop by adjusting the shape of that loop right there. The one in the MFJ remote tunable mag loop can be squashed a little bit. It helps get a little bit higher gain. Some of these, like the P loop that I have from Chameleon, this is rigid and you can't change it, okay? Sometimes these things are inverted. Now, a mag loop, and this is extremely important, have a null right there. And along this coming up out of the page, there's a null. So in other words, if you have a mag loop that looks about like this from the side, you've got a null that way and that way. That null can be used to advantage, and you can aim it at a source of interference. One thing that MFJ suggested was putting this up on top of your house horizontally. The problem is with my house, it's only up about 5 feet. It's horizontal, and it's got a null straight down, but it does not have a null over here. And there's other household equipment in there that can create problems. So there's your basic magnetic loop. You've got a whale of a big capacitor up here. And if you look at it, you've got a loop which is inductive, and you've got a capacitor which is capacitive. This is a tuned circuit. Okay, and because you're trying for very low resistance here, which is why you're using the outer shield of a coax, or you're using a pipe. The MFJ ones, I believe, are made of aluminum pipe that's been rolled into a 3-foot circle. By the way, they are shipped in a big box because the thing is shipped fully assembled. Now this capacitor up here, you've got a problem. You're driving it down here. This is your low voltage, apologize for my hand shakiness, high current here, along here. This is your low current, high voltage here. This capacitor has to be able to withstand the voltage that goes across it whenever power is applied to this. Now this is where mag loops start to differ from each other. Okay, there has to be a way to tune that capacitor, because that's how you tune the magnetic loop. Okay? You have to be able to tune the capacitor. So if you have low voltage from low power, and by low power I mean, say, less than 10 watts, okay, you tune this until the SWR dips dramatically down to close to 1-to-1. Okay, it won't ever be quite 1-to-1 because the resistance is going to be somewhat different from 50 ohms in this pickup loop right here. Okay, this is the loop, it's where it's fed. Some of these antennas are inverted, so you have the capacitor and the tuning at the bottom. Now, the ones that are low power have a tuning knob right on the antenna. If you get like the Chameleon P-loop, this is down at the bottom. So you set the thing on a table and you tune that with your finger. Now, to make any sense of it at all, tuning that has to be done with a geared tuning indicator, because the thing is so high Q that you get that thing down there to where it's tuned, and it will, just a tiny fraction of a degree past that, it won't be in tune anymore. Now, the tuning width varies from like 40 meters. It can be less than 10 kilohertz. It may be even less than that, all the way up to 10 meters, where it can be 25 to 50 kilohertz. Okay, as the frequency goes up. The Q, remember Q is the, it's the reactance, total reactance, divided by the resistance. As the resistance goes down, the Q goes up. Now, the radiation resistance of a loop is very low, on the order of 3 or 4 ohms. So the ohmic resistance in this loop has to be extraordinarily low, and you need to keep it low because you've got one resistor that's radiation and one resistor that's ohmic in this thing here. You want this to go down, and this is low, but you want this to be bigger than the ohmic resistance so that it will radiate, and it does radiate. Now it is this is a little bit of a departure. Usually a tuned circuit is not a radiator, but this is an example of where it is, okay? This radiator will radiate on one specific frequency, give or take these little boundaries that I've put here. Now, there are a couple different here. Tuning. There is direct tuning, and there is remote. Okay? The MFJ are the main MFJ loops, the 1886 and the I think it's the 1888 or something like that. I guess I could look that up. Why don't we do that? Okay, yes, the MFJ 1888 super high Q loop, 36 inches in diameter, 15 to 40 meters, $579.95. That's $580. My first mag loop I purchased from MFJ with what then were channel funds. I had very few channel funds at the time, but I purchased this antenna. It came faulty, and I had to repair it, which MFJ allows you to do, and I took it apart and looked inside, saw the problem immediately, and fixed it. Okay. You can do that with MFJ. With other companies, if it doesn't work, you're going to have to send it back, because if you open it up, you avoid the warranty. But MFJ is very easygoing on that particular point. So you've got direct tuning, where you have to sit there with the mag loop beside you at a table. This is good for portable operation. You've got your QRP rig next to you, because the direct tuning are almost always QRP. And you tune the knob. You tune it like you do a tuner. You tune it for max noise. And you get a whoo as you go by it, and you can get right down on it. And then with your SWR meter, you can see how wide it is and where best to put your signal. Okay. Now, this brings up the point. If the mag loops are so high Q, how will you determine the spectrum of it on your spectrum scope that's on your radio? And the answer is you don't. If your radio has another input, you can use a receive antenna for it and actually get the waterfall. But this is very inconsistent with spectrum analyzers, because you just get a few kilohertz. Now, you can use your spectrum analyzer to help you tune, because as you tune, you will see the little patch of noise weaving back and forth on your spectrum scope. That can really help you tune. Now, normally the lowest frequency you get these for is 40 meters. But if you double the length of the loop, you only put the capacitor in one part of the loop, so the other loop bypasses it. You can go lower in frequency down to 80 meters, and it's really high Q down there. I mean, you can get to the point where it's not wide enough for an entire SSB signal. That's high Q. Okay, so the two types are direct tuning, where you have the thing sitting next to you on a table, and remote tuning. Now, some of the direct tuning are starting to incorporate remote tuning, but by and large, there are two kinds of power. There's low power, or QRP, and there's higher power. Usually okay for 100 watts. To build a loop antenna for higher power than that, you're going to need a monster capacitor, because it has to take care of the much higher power. What's the problem with power? Remember, I said this is the high voltage point on the antenna. It will arc across the capacitor, which is not good for the capacitor. It's not good for your radio, because it shorts. And it shorts, and that short goes back into your radio, and suddenly, instead of looking into a one-to-one system, you're looking into infinity to one. Very bad for your radio to do that. You could also, and by the way, don't use a tuner with these. This is how the tuning is done, right up here with this capacitor. So you won't use your tuner, not even to touch it up. Don't use your tuner. Let the antenna do the tuning, okay? Now you've got range, frequency range. Frequency range, okay? And you've got usually like 40, let's see, this one is 40 to 15 meters. MFJ has another one that's 20 to 10 meters. Now, if you want to go lower in frequency, you're now in the business of constructing your own. And you can put multiple loops on this if you want, and get higher frequency. Okay, so the advantages of a mag loop, they're small. If you want, you can take a remote tuning type like the MFJ 1788 and 1786. I would go for the 1788. You can stick it in your attic. Okay. Now, if you live on the East Coast, one of the problems is that if you put that thing this way, put it this way in your attic, and you're on the East Coast, most of your signal will go this way, and you won't have much to the west. So some people put them on rotators. The rotator can, even for a cheap rotator, can cost as much as the antenna. Okay, even the cheap ones. If you can find a rotator, television rotator, somewhere where they sell televisions or look online, you might be able to get them a little cheaper. There's very little mass here, okay, except in the capacitor. All right, and so you can turn the thing to get different frequencies, or I'm sorry, different directions. Tune the thing to get different directions. Yes. So the problem with the low power QRP is they just use off the shelf capacitors in here of the kind that you see in old radios. Okay, and they put them in here. To get high power, you've got to get a capacitor that's manufactured by hand. The plates are usually like so, and they're separated by about so. And you get, often what happens is they'll have a set of plates here, and then a set of butterfly wings, so that the butterfly wings can come down and address both of those sets of plates at the same time. So you actually have two capacitors in series. And then you can go the other way to where the butterfly wings are completely out of the capacitor down below, and you end up with nothing. No capacitance. Let me just show you what that means, because this is a common technique for doing this. Again, we're dealing with very high voltages. So the way this works in the MFJ, you've got plates like this on this side, and down here they are literally heliarched to the aluminum pole, okay, as it comes in. So you have no resistance like you might get with a screw or something like that. It's welded to it. Then you have the other side coming up over here, and you've got plates over here, and again welded. Now running up the middle, we've got our plates here. We're now looking at them from the side, and we've got a butterfly that's partially in, partially out. I wish that were more symmetric. I'm a terrible artist. That can move so that you have the butterfly up here, and you get a different amount of capacitance. Okay? Now that's two capacitors in series, which means you've got to have a lot of capacity here to get a decent amount of capacitance at the top. Now, I have seen some hams who make homemade loops. They'll put it like this, and then at the top, for the capacitor, they'll put a piece of coax cable, because coax has a certain amount of capacitance per foot, and you treat that as a capacitor. Then you attach two plates here that are like printed circuit board material, and you can slide those back and forth against each other to vary the capacitance in here. And then you put your loop in here, and you've got a homemade loop, and you can save hundreds of dollars. But it's a stinker to tune, of course, no repetition to it. Now, as far as the tuning is capable, you've got the hand knob. It's usually like a 1:8 ratio. So you've got to turn it 8 complete turns to get your capacitor to turn a turn. Okay. Or you have a remote tuner, and these vary quite a bit. The very simplest one is a stepper motor that moves the capacitor Nice thing about this is it is repeatable. Certain amount of steps, you get a certain amount of capacitance. Although heat, and I have had this problem, as the day gets hot, the plates expand, changes capacitance, you have to retune. Okay, a stepper motor or just a DC motor, by making it go one way, it'll increase capacitance. Making it go the other way, it'll decrease to get the right. This is very hard to narrow in on just the precise spot. Other remotes are like the MFJ, where you tune while transmitting, and it's got an SWR measure in there, and when the SWR gets low, it will stop. And then you've got some very fine-tuned buttons on there to get it just exactly tuned right. Once you've done that a while, you get very used to it. I've done it with my MFJ. Now, some of the newer ones are getting automatic. Okay, that's cool, because then if you transmit a frequency, usually on tune but without the internal tuner on, it will read the frequency, it will go directly to where it knows is a good match, and it will then fine-tune it for that. Okay, that's very nice. Some of them even attach to the radio so that it knows the frequency, it looks in its memory, and as you're tuning this way, it will be tuning the antenna at the same time. Those start to get expensive. So these here can be had for $300 to $450. These are like $600 that tune while you transmit. Okay, and you can pay as much as $2,000 for one of these super automatic ones. There's a company in Italy that makes these. They're called baby loops. They're nothing about them is baby. Okay, they're very expensive. Now, what are the advantages and disadvantages of mag loops? Okay, disadvantage and advantage. The advantage is size. These are small. You can put this on your back porch, even if you're in an HOA area. Nobody knows what the thing is. So you sit it on the back porch and put a flower pot in front of it, okay? And some flowers. I even saw one person who put this up on a stand and hung a birdhouse underneath it, and then wrapped some fake leaves around it. And from a distance, you couldn't even tell it was there. Okay, so they're small. These are very good for people with HOA issues. Okay, you're giving up the broadband tuning, but you've got something that works. By the way, mag loop works about as well as a dipole at the proper height. Okay, they're good antennas. They really do work. Okay, now because they have a null, they have a bit of gain off the edges, but not very much. So they're HOA friendly. No one even knows you have a transmitter, and it can cover 40 through 15 all in one thing, and it's just a loop. These are about the size of a hula hoop. Okay? Now that baby one I mentioned from Italy that's $2,000, by the way, you can get it through DX Engineering, is very HOA friendly. It can be parked anywhere. You can actually mount these on the ground, although I would give them a little height. My very first tests of mine were at 9 feet in height, and it worked fine. Okay, so the size, the HOA friendly part of it. The disadvantage is the high Q. You're not going to be able to look at a spectrum scope, but there are all kinds of ways to mitigate that. with tuning and things like that. Like with the MFJ tuner, you quickly become very aware of how to best and quickly tune that particular antenna. Okay. Another thing I should say here under advantages, they're portable. Even without disassembling them, they're portable. Now, Chameleon makes a P loop and an F loop. I have the P loop. I think the F loop is the only one still in their catalog. But these come where you can break them down and put them in a courier bag, which is the kind of bag you put over your shoulder. Okay, all the parts are in there. You can put your radio in there too. You can put a battery in there, and you've got a complete portable station on your back. Okay, they are portable. Very high Q, which means tiny bandwidth. Okay, now they are susceptible to temperature, meaning as the sun comes up, it will slightly expand the elements, which will throw the tune out. So you'll have to retune as they get warm for temperature, or as you go into the evening, they start to shrink. And yes, that will actually affect the tune notes. The point is that loop antennas come in a variety of categories. They all seem to kind of look the same, but they come in quite a variety of categories, from handling just a few watts to handling 100 watts to the baby loop from Italy that can handle quite a bit more, all the way up to 1500 watts. At that point, you have a huge capacitor. Okay. There are a variety of ways to make them. It is possible to home make them, but take some real work to get an efficient one. The key thing about a mag loop is that it's got to have very low radiation resistance, and the radiation resistance has to dominate the ohmic resistance, so that's why you're using pieces of pipe and stuff like that to get very, very low resistance. So if you would like to support this channel financially, you certainly may by going to dcasler.com/support. One of my favorite ways right now is to become a patron of this channel by going to patreon.com and pledging a certain amount every month. One of the benefits we're giving to Patreon members is that once a week, my assistant selects a video and puts it up on Patreon several days in advance of when it goes up on YouTube. So you get a little bit of a sneak preview on that. So there you have it. Please click like. Please subscribe. Please comment. And until we next meet, 73.